All right, so diving some more into some geometry. We're going to start with a few definitions. A ray is a geometrical construction that starts from a point and extends forever in one direction, kind of like a line, but instead of extending forever in both directions, it does have one terminal point. A line segment, right, would have two terminal points, and you'd be able to measure the length. A ray is still infinitely long, but it does have one endpoint. So an angle then is formed by the intersection of two rays. So when you have the endpoint of two rays being the same, that'd be this guy, we call that the vertex. The rays extend forever in both directions, right? Those are the sides of our angle. Then we have the interior, and then obviously the exterior of the angle. There are lots of ways to name an angle and lots of ways for angles to overlap. So if we, for example, were looking at this schematic and it said to name all the angles that have B as a vertex, that's this point right here. Okay, so I could use angle A, B, D. You can't just say angle B, right? Because that could mean way too many things. So we have to use three letters to name an angle. The middle letter is always the letter that is the vertex. So we've got angle ABD, which is also angle 1. We could call it angle 1 because there's only one angle that can be angle 1, right? Then we have angle DBC, which is angle 2, or angle, let's see, ACG. I guess I wouldn't have B as a vertex though, would it? So really those are the only two that we're able to use that have B as the vertex. This one uses the line or the ray going through B as a side, as does this one, but only 1 and 2 would have B as the vertex. To measure angles, we use three different vocab terms. We've got acute, right, and obtuse, and that covers all of the possibilities for the size of an angle. Acute means that it is less than 90 degrees. Right means it's equal to 90 degrees, and obtuse means it's greater than 90 degrees. We would use a protractor to measure angles physically. We're not going to be doing that, obviously, since we're not together right now, but protractor is the tool used to measure angles. You put the vertex down here. There's usually a crosshairs or a hole in the protractor that you line up with the vertex. You put one of the sides on 0, and you'll notice there are zeros on both sides of the protractor. So you'll see two sets of measurements. One goes from left to right, 0 to 180. The other one goes from right to left, 0 to 180. And that's just for convenience. But that means that it's very important that you notice which 0 you're using so that you don't get the angle backwards. If we're using the 0 on the inside, that means that we just look backwards along the protractor until we find the angle measure that the other side intersects. In this case, 50 degrees. If we were measuring this angle going the other way, it would be 130 degrees. So it's important that you know which scale you're using on the protractor, because you can measure them two different ways. Okay, so like I said, three ways that we can classify an angle. Right angle means it equals 90, acute it's less than 90, or obtuse it is greater than 90. Two angles are congruent if they have the same measure. The symbol for congruency is an equal sign with a tilde on top. Okay, I'm going to keep moving, but pause this if you want to put this in your notes. Adjacent angles are two angles that are on the same plane. That just means they're drawn on the same piece of paper, right? You can't have them floating in space from each other. So adjacent angles are two angles that have a common vertex and a common side, but no common interior points, meaning the angles don't overlap, they just bump up next to each other. So in this case, 1 and 2 are adjacent. They share a vertex, they share one side, but nothing that's inside x can be inside y, right? Or points that are inside angle 1 are not inside angle 2. Okay, same thing here. With these two, they share a vertex and a side, but no overlapping points. We've got this stuff over here and this stuff over here, but nothing overlaps between the angles. Things that are not examples in this case, ABC, so this angle and angle 3 are non-adjacent because they do have overlapping interiors. So if I highlight this to show you, ABC is the yellow stuff, right? That's the interior of ABC. And the interior of angle 3 is right here. That overlaps, so they are non-adjacent. And same thing here. We got angle 3, and then ABC. They don't even share a vertex. They do kind of share a side, where their sides are on the same line, but those are non-adjacent. A linear pair is a pair of angles, a pair of adjacent angles with non-common sides that are opposite rays. For example, here we have angles 1 and 2. Notice that they have the non-common sides are opposite rays, rays going in opposite directions. You could also say that these two angles make up a line in a sense, because you use a line, you throw a ray off of that line, and you have two angles. And you'll see that linear obviously refers to line, and that's where this comes from. Okay. ADB, that's this guy, and ADC, this guy, are not linear pairs because their two non-common sides are not the same line. There's an angle there. And then finally, vertical angles are two non-adjacent angles formed by two intersecting lines. So if you run two lines through each other, you get vertical angles. So 1 and 4, or 3 and 4, or 1 and 2 are vertical angles. They're opposite each other, and they're formed by intersecting lines. We do not have vertical angles over here because this line bends, right? It's not straight, so it's not in a line. Again, go ahead and pause if you want to put any of this in your notes. I'm going to keep moving. So a few things to take notes of here. Vertical angles are always congruent. Vertical angles are always the same measure. So when you have two lines intersecting, the pairs of opposite angles are going to be congruent. They're going to have the same measure. If this one's 30 degrees, then so is this one. That makes this 150 degrees, and this would also be 150 degrees. Complementary angles add up to be 90 degrees. They can be adjacent, they can be connected, or they can be separate. Either way, if they're complementary, if their measures add up to 90. Supplementary angles have measures that add up to 180. Again, they can be a linear pair, they can be adjacent, or they cannot be adjacent. It doesn't matter. 3 and 4 are supplementary because they are a linear pair. Angles P and Q are supplementary strictly because they add up to 180 degrees. I know that one struggle for some is going to be keeping complementary and supplementary separate and remembering the difference between those two definitions. One method you can use is that supplementary has 2 p's in it, complementary only has 1, and supplementary angles add up to be twice as much as a complementary angle. So complementary angles add up to 90, supplementary angles, 2 p's adds up to double that, or 180. There are other tricks you can use if you struggle to keep those tell them apart, whatever works for you. And then finally, like I've already mentioned, linear pairs are supplementary. So if you have this line and you throw a ray off of it, the two angles that you create will add up to 180. Find the measures of two supplementary angles if the difference in the measures of the two angles is 18. So we need to write some equations here. We know they're supplementary, so whatever x and y are, they add up to 180. But the difference is 18. So I also know that x minus y equals 18. Now I don't know if it's x minus y or y minus x, but it doesn't really matter because it doesn't say which angle is bigger to begin with. This is a system of equations, and we know how to solve that, right? I can just add these two equations together. 2x, y plus negative y is 0, and 18 plus 180 is 198. Divide that by 2, and you're going to get 99. So if x is 99, that means that x minus y has to be 18. So 99 minus 99 minus y equals 18. So I'd subtract 18 from both sides. We're going to get 81 equals y. Perpendicular lines meet at right angles. Hopefully we all knew that. That's kind of the definition of perpendicular lines, two lines that cross such that the angles formed are 90-degree angles. So a question the book might ask is find x and y so that lines PR and SQ are perpendicular. Hopefully you remember from sections 1.1 and 1.3, but when you have a uh, a name like this, when you see those two arrows, you know that's a line. So PR is this guy, SQ is this guy. We don't care at all about TW. That's just there for giggles. We want to say find X and Y so that they're perpendicular. So we're going to assume that that's a 90-degree angle and then do some algebra to figure out what they would need to be. So what I notice is I have this angle up here and this angle right here that should be not only vertical angles, but also supplementary, because they should both be 90 degrees. So what I might write is 4y minus 2 equals 2x plus 5x plus 6. And you could try to solve that, but we have two different variables, so that's not going to work just yet. We could also say 4y minus 2 is equal to 90, because that should be a 90-degree angle. So 4y equals 92. So y is going to be 92 over 4, or 23. Then I could take that 23, plug it in right there, and solve that guy. So 4 times 23 minus 2 equals 2x plus 5x plus 6. This is 90, which makes sense because this angle should also be 90 degrees, equals 7x plus 6. So we subtract 6 from both sides. 84 equals 7x. 84 divided by 7 will give us 12. So those are the two values for x and y that would make those two lines parallel. If x and y are anything else, or sorry, not parallel, perpendicular. If x and y turn out to be anything else, then those two lines would not be perpendicular to one another. Okay. In the figure at right, it appears that line FG is perpendicular to line JK. That's what this upside down T means. It means perpendicular. Sometimes you'll see a little 90-degree box in there, but not always. However, we can never assume this unless we've given other information. So if there's a little perpendicular box in here, then yes, you know those are perpendicular. Or if it says that measure FHJ is 90 degrees, that would do it too. But you can never assume just from a picture that something is perpendicular or that two angles are congruent. And I will have this argument with some of you. No matter what I say, both this year and next year, you'll say, oh, but they look perpendicular. Oh, but they look congruent. Well, they certainly might, and they certainly might be, but we cannot use that as information. We need to find it in a mathematical way, whether it's given information or it's something that we prove or verify using some other properties of the figure. Okay, so in the textbook, all figures that you see, all drawings, all sketches, whatever, they are just going to be pictures to help you unless things are marked, right? So you could also see in a book or in my drawings an angle like this, and if I mark it like that, that's a 90-degree angle. Realistically, is the angle I drew 90 degrees? No, of course not. But if I mark it that way, then that means it's 90 degrees. Always trust the markings more than the picture itself. Okay? Don't fall into that trap. I know some of you will, and I'm going to bring this up again, but try really hard never to base your assumptions or your information on the picture. So determine whether each statement can be assumed from the figure and explain. So I'm going to let you pause this for a second. We're going to make this a yo-yo. So pause this. Answer these three. Determine whether or not they can be determined from the figure, and then unpause and we'll talk about them. Okay. So A, KHJ. So let's find that. KHJ is this guy, and that was marked. And GHM, that's this guy, are complementary. Do they add up to 90 degrees? I don't think so. There's nothing there to indicate that those should be 45. Okay. Those two markings that I just covered up indicate that they are parallel to or congruent to one another, but they can't be not complementary because there's this mysterious angle here. This one's 90. So if there were only two other angles and they were marked congruent, then I can say, oh yeah, they would have to be complementary because this whole setup needs to add up to 180. But the two congruent ones plus the 90 plus this add up to 180, and that's certainly not 0. So they can't be complementary. B, GHK. Let me erase what I have over here. GHK, which is this angle, and JHK, which is this one, are a linear pair. What do you think? I think yes. They share a vertex, they share a side, and the other two sides are opposite rays, meaning one line. Two rays going in opposite directions, so that's a yes. Finally, C. HL is perpendicular to HM. So there's this guy and this guy. Are they perpendicular? Yes, because it's been marked as a 90-degree angle. And I know that if I have a 90-degree angle, we have perpendicular lines. And I know that if we have perpendicular lines, we have a 90-degree angle. So because that's marked, then yes, I can assume that's true. Okay. Good luck with the homework. As always, reach out, shoot me an email if you have any questions, and have a great day.